Imagine you're heading from the Narendra Modi Stadium in Ahmedabad after the Coldplay concert. You open Ola or Uber and suddenly the ride fare doubles or triples. Freaky. No, it's the algorithm reacting to real-time demand. Welcome to 404 Explained, where we simplify the complex tech of tomorrow that others leave unexplained. Over January 25-26, 2025, Coldplay performed to a combined crowd of about 2.2 lakh people in Ahmedabad, making it one of India's biggest ever concerts. Ahmedabad Metro recorded a record 4,05,264 passengers journey across the 2 days, around 1.5 to 1.8 times the typical daily load, and extended services until 12:30 am to manage the crowd. It wasn't just the Metro cafe spikes too. Gujarat Samachar reports that during the January 25 Coldplay concert, Uber, Ola and Rapido trips from SG Highway to the stadium jumped from about 250 to 623 rupees and from Sheila to 553 to 678 rupees, all due to the massive demand. That's 2x to 3x multipliers automatically applied by the algorithm, triggered when demand far outweighed available drivers around the stadium. It was purely supply and demand playing out in real time. Concert surge is equal to algorithms addicted to imbalance. So when your 500 rupee ride turned into 1200 rupee at the stadium gate, it wasn't personal. It was data demand and dynamics colliding. Could Uber predict the surge before the concert even ended? Yes. We'll explain how. Alright. So how do these apps know what's going to happen before it actually happens? Like during the Coldplay concert in Ahmedabad, how did they predict that your ride home would be chaos? The answer? 2 words. Historical data. Ride-hailing platforms collect data from every major event in a city. Concerts, cricket matches, even Navratri celebrations. They don't just store demand surges. Their training data captures exact pickup and drop zones, time windows of peak bookings, average wait times, fare trends, app opens versus actual bookings, and weather conditions. So if Coldplay's show happened at the same stadium where an IPL final did last year and both have 50k plus people attending, the system connects the dots and says, demand between 9:30 and 11 pm around Motera, hot zone. That's historical training data, the backbone of the entire algorithm. Next, this data trains a machine learning model, basically a system that finds patterns humans might miss. Let's break it down. Inputs: date and time, event data, app usage spike, weather, nearby transit closures, driver availability, output, predicted demand hotspots, price recommendations, driver supply gaps, search probability. And it does not stop at one event. These models are constantly learning. After every big night, whether it's Coldplay in Ahmedabad or New Year's Eve in Mumbai, the system looks at where it predicted demand, what actually happened, and how it can do better next time. It's called retraining the model, and it makes predictions sharper over time. It's like prepping for semester finals. After every mock test, you check mistakes, tweak your notes, and your next score jumps. That's the model learning from each exam night. So the next time you see search pricing light up on your phone, know this. It's not random. It's not because of Coldplay. It's because a model trained on years of real-world data said, trust me, demand's about to spike. From stadium lights to search pricing, what seems like chaos is actually a high calculated forecast. Apps such as Uber, Ola and Rapido are in a constant price chess match with each other. If Uber predicts a surge but Ola doesn't, you will see people switch in seconds. So platforms use real-time data not just to raise prices but to stay competitive. They might even lower fares temporarily to grab riders before a rival app does. In a city like Ahmedabad after a Coldplay concert, that competition gets fierce. Picture this. You're standing on a rainy Friday night, umbrella in one hand and phone in the other. You open your ride-hailing app and it hit book now. In that single moment, an entire invisible orchestra of algorithms comes alive. First, real-time GPS and crowd sensing kicks in. Your location, along with thousands of riders and driver signals, paints a demand density map that updates every few seconds. Then, the system pulls in weather and time analysis. It knows rain usually spikes demands. Weekends keep people out longer and holidays create traffic surges. Prices start adjusting before you've even blinked. Meanwhile, dynamic driver incentives quietly go to work. Push notifications are pinging to idle drivers, even nudging those far from hotspots to head your way, swelling the fleet exactly where it needed. But it's not just your app watching. Instant competitor tracking means your ride's algorithm is also spying on rival fare multipliers, ready to match or undercut them within seconds. The city, it's been sliced into hundreds of microzones. Search pricing here might be different from a street 2 blocks away. Sometimes a 50% fare difference in the same city. And to make the lightning fast, advanced cloud infrastructure processes massive real-time data streams instantly, ensuring search pricing reacts faster than you can blink. Finally, driver supply optimization balances it all, adjusting prices, attracting just the right number of drivers, and keeping your wait time low without overshooting. So in the time it takes for your thumb to tap book now, multiple ML models have already predicted your wait time, calculated the optimal fare, nudged driver availability, and secured a competitive edge. That's predictive pricing. Fast, agile, and ruthlessly efficient. Let's lift the hood on what powers your ride-hailing app. It's not just magic, it's pure machine learning muscle. First, the data ingestion pipeline. Every time your phone signals, "I'm here," a driver's GPS updates, or the weather warns rain's coming. All that info streams in real time through systems like Apache Kafka or AWS Kinesis, the app's bloodstream. Next, feature engineering transforms raw chaos into clear signals. Raining at pickup, driver supply nearby, average wait time, or concert alert. This helps the ML brain spots patterns, not noises. Then, demand prediction models. Using gradient boosting and neural nets, forecast surges citywide minutes ahead. Here's the kicker. The pricing engine crunches these predictions, calculates search multipliers, and sends them to your apps in under half a second. Behind it all, geospatial indexing. Think Uber's honeycomb grid breaks the city into tiny cells, each with its own price tag. Load balancing and latency control ensures lightning fast responses, so your fares reflect really without lag. And the best part, every ride, every decision feeds back into data lakes like snowflakes, training models daily or hourly to keep your pace with a city, moving faster than you can say, "Where's my cab?" So next time your fare jumps in seconds, remember, it's not magic, it's a high-speed AI machine running under the hood. Your ride fare isn't random. It's calculated using demand, location, time, driver availability, and even events nearby. This concept, known as dynamic pricing, traces back to the 1950s but has become far more advanced today. Studies have found fares can even vary by phone type, with iPhone users sometimes paying more. Some argue it's smart economics. Others call it algorithm manipulation hiding behind a glossy UI. So next time your ride home jumps from 250 rupees to 450 rupees, ask yourself, not just can I afford it, but also, do I deserve to be charged more because I'm desperate? Next time you're booking the cab, just remember, sometimes a set of algorithms just ran a race to decide your fare. Curious about the magic behind these algorithms, or dreaming of building smarter, faster AI systems yourself? Begin your journey with NIIT's programs in data science and artificial intelligence, and join the tech revolution shaping the future of rides, pricing, and beyond. Link in description. And if you have enjoyed this episode, hit like, share it with your FareSpeed buddies, and subscribe for more episodes of 404 Explained, where we decode future tech in a way that just makes sense.